Okay, so I hope you have already watched the video that I recorded on the complex power. So definitely watch that first. If you haven't watched it, please watch that first because I explained about different powers and basically what is the method to given some of the parameters, how we can find the other parameters. Please watch that first. But now, let's say you have watched it, and now let's look at this question. So we are given 3 loads and they're all connected to a voltage source, and the voltage is given as 300 volt RMS. So everything after this will be RMS. If they mention RMS, it's gonna be RMS, everything will be RMS. If they did not mention it, then it's the maximum. In this case, it's RMS. And the phase is also, they didn't give any phase, but the underlying assumption is that the phase is 0. So whenever it's just, they don't give you phase, like in this case, 300, it's just phase 0. But they're the same thing, so that's the same thing. Sometimes they just don't put the phase equal to 0 as it's the same thing. Okay, but just know that because this is just 300 volt, the phase is theta v basically 0. So that the theta v, and then the 300 volt is basically the magnitude of the RMS. Okay. So the problem wants us to find the current, but for each load, some different informations are given. So this is a very, very good practice problem. So let's see. For load 1, it said load 1 absorbs 3 kilowatt at unity power factor. Okay, so let's. So for load 1, it says absorbs. Load 1 absorbs 3 kilowatts. So from the unit, it's watt. So I know it's P. So P is 3 kilowatts. And it says unity power factor. So unity power factor means that power factor is equal to 1. Okay. So we remember that from the power factor, somehow I can get the information about the phase. And at the end also I want to find I1. Okay, so find I1 given this information. Okay, so power factor I know is cosine of theta v minus theta I, and in this case it's unit, it's 1. So cosine inverse of 1. So I have to get the cosine inverse at this step. Cosine inverse of 1 equal to 0. So another for theta v minus theta I equal to 0. Theta v was 0. So therefore theta I is equal to 0. Okay. Very good. So I know the phase of the current is 0, but I need to know also the magnitude. So again, based on the video that I had, you know that when, for example, you have P, and then we have also the power factor, we want to find the magnitude. I will just go for this formula. P equal to magnitude of the RMS, magnitude of IRMS, times the power factor, which is cosine of theta v minus theta I. So P is given as 3 kilowatts. Magnitude of V of RMS is given as 300. The magnitude of current we need to find out. And the cosine of the theta v minus theta I power factor is equal to 1. So from this, the I magnitude is 3K divided by 300, which becomes, I guess, 10, right? 10 amp. So now what is I now? I have its magnitude and I have its phase. So I can write therefore I1 was the load one, so it's I1, and I will just also say RMS as the magnitude, which is 10. The phase is 0 amp. Again, just I want to make emphasis that again can put RMS, so no, you know that's the RMS value. If it's maximum value, just it was maximum value. But because it at the beginning they gave us RMS, everything after that would be RMS. Okay, very good. So again, very simple. I had P and power factor. From power factor, I got the angle, some more information about the angle, phase. And from the P, I got the information about the magnitude. I just put them together. So this is I1. Now, let's do that for load 2. For load 2 absorbs 5K VA, okay, at 0.8 leading. Okay, right. So L2 VA is the unit for the apparent power, basically. So it says 5K VA. I know that apparent power is magnitude of S. Okay. And then it says the leading power factor 0.8 leading. Okay. Power factor is 0.8 and it is leading. Okay, right. So from this, we would like to know again the I. What is the I for the second loop? That's I2. Okay, so let's start with the power factor. So we have to take the cosine inverse. So cosine inverse of 0.8. Let's see, it was, I calculated that cosine inverse. So cosine inverse of 0.8, I checked it. It's you can use your calculator at this point, 36.8 degrees. Okay. But then the information definitely here, we have to look at if it's leading or lagging. Okay, it's leading. It is leading means that I is 36.8 degrees ahead of V. Okay, so wherever V is, I is 36.8 ahead of that. But now let's look at the V. Remember, theta V was 0. So if therefore, if theta V is, if V is here, let's say if this is V, then I is, this angle is 36. Yeah, so this information about the leading tells me this case. So therefore, from this, because again theta B was 0, then theta I is, so putting these two information together, theta I is 36.86. Yeah. I should add that. Okay. So as an extra practice, let's say just let's assume another scenario. Let's say everything was the same, but if we had 0.8 lagging, if it was lagging, it meant that basically I is behind V. Now V was 0. So if this V got to 0, the phase was 0, then I was here, then theta I was negative 36. Negative 36. Just be mindful of that this leading or lagging basically determines which one is ahead of the other one. And based on that, you will know exactly what should be the phase of the current. Okay, so the red part is another scenario. But in this case, because it was leading, I leads, and it theta V equal to 0, so the other one is positive. Theta is 36.8, very good. So I got the phase of the current. Now I need to get the magnitude of the current. Okay, that's I can find from this other information. I have magnitude of S, again based on the video that I had or the formula that you already know. Magnitude is magnitude of VRMS times the magnitude of IRMS. Magnitude of S is 5K. Magnitude of V was 300 from the problem was given, times the current of IRMS. So the current of that is 5K divided by 300, which is basically 50 over 3 amp RMS. And just put these two information together, theta I and the magnitude phase and magnitude. So I2 RMS is 50 over 3 with the phase of 36.8 amp RMS. Okay, very good. Now, as a reminder, now if in another scenario, let's say Q and power factor were given, if let's say this is not this problem, but in general, like, let's say somebody gives you Q and power factor. So again, from the power factor, you get the cosine inverse. Somehow you get some information about let's say the scenario theta I, again, based on leading or lagging, just be mindful of that. And from the Q, you can get the information of, again, the magnitude using this formula. We know that Q is equal to the VRMS, IRMS, times the sine of theta minus theta. Okay. So let's say you have Q, you have the voltage. And theta V minus theta I, you already have theta V minus theta I from power factor, but you have to get the sign of that, which is fine. And then based on that, you can get the magnitude. So you get the magnitude, you have already found the phase, and then again, you can put them together to get the current, okay? So now in the, here, we could also look at the load 3. It's a very similar thing. Let's say for load 3, what information do I have? For load 3, it says absorbs 5K watts and delivers 6K var. Okay, so P is given as a watt, and 6K var is the Q basically, and also it's delivering. So let me bring a new page. Okay, in that scenario, for load 3, P was given as 5 kilowatts, and Q was given as 6 kilowatts, but see, delivers, because if delivering a power, it's negative. Again, these are like the little things that absorbing positive, delivering negative. Because it delivers, you get negative 6K. Wow. So this is because it is delta. Okay. So pictorially, if this is P 5K, then the Q is negative 6K. And this is S. Okay, now if this information are given, so as before, there are probably different ways of doing that. You can, given that I have 5K and negative 6K, I can find theta V minus theta I by getting a tangent. In this case, it's tangent. So as we know, tangent of theta V minus theta I is Q over P. So therefore, theta V minus theta I is equal to tangent inverse of Q over P. Q is negative 6K divided by 5K. So this angle would be minus, let me calculate it. So this is almost 50 degrees. So theta v minus theta I is negative 50, and theta v was 0. So from that, theta I is 50. So therefore, we have the phase of the current from this information. And we need to find now the magnitude. So that's also we can go for, because we have P, we can again say P equal to V RMS by RMS times cosine of theta V minus theta. So we have P as 5K. We have the magnitude as 300. We want this. And theta V minus theta I already have theta V minus theta I, which is minus 50 degrees. Find the cosine of that. And then you can find the magnitude of I. And again, I would be, this is the third look, the magnitude times the phase. Okay. So I don't do the math here, but that's from note 3. Let's see what else we have. So therefore, see, so far we could find the current in all these situations. Now, part C, it says for these loads, also find the complex power. Okay. So remember now at this point, then going back to load 1. Oops, sorry. To load 1, at this point, I have its voltage and I have its current, and I want to find S. Yeah. So I would say you can just do this formula that S is the magnitude of VRMS, the VI basically, times the phase, which the phase is theta V minus theta I, because you already have all of these. You already calculated theta V minus theta I, you have this, you have that, and you find S. And remember, at the end, it's a phasor. So it's a complex power, it has some magnitude and it has some phase. For all the cases, for L1, L2, L3, all of them, because you already had this information. Magnitude of VRMS, I, magnitude of IRMS, and then theta V minus theta. This is S. And again, I don't do the calculation, please do that yourself. But it's just straightforward. And at the end, find the Z1, Z2. Okay, so okay, again, Z, that's a Z1, was V1 over I. So the voltage was 3 with the angle of 0. The current, what was the current for the load 1? The current was this one, 10 with the angle of 0. 10 with the angle of 0. So that gives me 30 ohm. And the phase is 0. So this is this is just a resistor. Okay, but let me also do the Z2. So Z2, voltage V2 over I2. So the voltage for all of them was 300. But what was I2? I2 was 50 over 3 with the angle of 36.8. So 50 over 3 with the angle of 36.8. Okay, so at this point, we have to this becomes 6 and then times 2, 18. Okay, look at the phrase. 0 minus 36.8. So this is ohm, but it would be also good to convert it to the Cartesian because we want to know what's the elements, what is R, what is L or C. So let me convert this to Cartesian. Basically, 18 times cosine of 36.8 minus sine of 36.8. Okay. J minus J times sine of that. So let me do the maths. Okay, I used my calculator. The cosine of 36.8 happened to be 0.8 minus J sine of that almost 0.6. Okay, just assume these are the numbers. So 18 times that 0.8 minus J times 18 times 0.6. So that gives me R. Oh, and this is negative, so definitely the capacitor. And even we can find its value. Minus J over omega C is equal to minus J 18 times 0.6. C. Negative J cancel. And let's say if I have omega, then you can find C. Okay. So in other words, this is 1 over omega, because it's negative J, so it's a capacitor. So this factor is 1 over omega C. And I'm not sure in this problem if the omega was given or not, because I added this part myself. So let's say somebody gives you omega. Let's say omega is 100 radian per second, okay? So therefore, 1 over omega C, which is 1 over 100 radian per second times C, is equal to this number. So from this, definitely can find C, right? Okay, right. Now, if it's positive, if it was positive, happens to be positive, then it's J omega L, right? And then given omega, you can find L. Okay, like